Continuing on with the net ionic equation worksheet, and remember, you've got to get these perfect so you can get them on the AP test. But what you've got to keep in mind is that there are thousands of reactions that you will probably never be able to predict their products. What you want to focus on are the thousands and thousands of reactions that you can predict their products. So that's what we want to focus on. Now, in the last video, we looked at a couple of reactions that were double replacement and a reaction that was synthesis. Here we're looking at single replacement right here because we're going to start here with solid magnesium ribbon, and we're going to add to that, we're going to place that in an aqueous solution of copper sulfate. Now, if you're in my classroom, you have carried this lab out, and you know that it's a single replacement reaction. We get some pure copper. It kind of looks like rust. Although it's pure copper, it's sitting there on the surface of the magnesium ribbon, and we know that in solution, then, we have to have magnesium sulfate. So we've got magnesium sulfate in aqueous solution. So we know that the sulfates are both in aqueous solution, and so we're going to cancel those out as spectator ions. So we're going to have magnesium metal. Now, one of the things you've really got to avoid is just writing in copper here, and because you've got to remember that the copper here is in solution. It's the copper 2+ ion. And over here, the copper is metal, so it has an oxidation state of 0. And we've got magnesium with a 2+. So our equation is balanced. The charges are balanced. And it says, what's the spectator ion? And you're going to write you're going to write SO4, sulfate. You've got to write the charge. Don't leave that off of there. What were you thinking? Yeah, there is the spectator ion. It has to have its charge, or it won't be the correct formula. Moving on to B. Hydrochloric acid. Let's see, just going to choose a different colored pen to separate the problems here. Come on, red pen. Hydrochloric acid, just kind of doing a rough sketch up here of the equation, is added to a solution of cobalt 2 nitrate, and so that's the overall formulas. Of course, you know that those are both going to be in aqueous solution. Hydrochloric acid is a strong acid. Cobalt nitrate, nitrates are always soluble. So it reacts, and we're going to have here, what kind of reaction is going to occur? Well, we've got cobalt ions floating around in solution. And we know that cobalt is a transition metal, and transition metals, when you combine them with things like chloride ions, tend to form complex ions, and that's exactly what we have going on here. Now, this kind of reaction has showed up over the last few years on the AP test, and so if you see a transition metal in some Lewis base, or ammonia or something like that, the hydroxide, the things that we've pointed out will form these complex ions, well, that's probably what we're going to make. So cobalt and chloride is going to be the complex ion. Now, what's the formula going to be? Well, what we said was that if you look at this charge on cobalt, you're probably going to, usually you're going to get twice as many ligands. So that was a charge of +2, so we're going to put a +4 here. So that is the complex ion that's formed. What is its overall charge? Well, chloride is -1, and we have 4 of those, so that's -4. Cobalt, remember, was +2, so the overall charge here is 2-. So we're going to clean this up and leave you there with the net ionic equation in the box. Now, what's the name of this product? Well, the name of this product is, there are 4 chlorines, so that's going to be tetra, and our complex our Lewis base here is chloro or chlorine, so that's going to be tetro, let's see, CH, I can't spell chlorine here, CHLOR, tetrochlorocobalt. And what's the charge of the cobalt? The cobalt here has a charge of 2+. So that's the name of that ion. So that kind of problem is a little less common on the AP test. So if you're not familiar with it, you can look it over, but I'm not going to tell you it's not going to be on the test, that those complex ions won't be there. So let's move on to C. C you're probably going to find is a little bit easier. Now we've got potassium carbonate, C2CO3. You know it's going to be in solution. In fact, in this particular case, though, it doesn't matter a lot whether it's in solution. You're going to get a similar kind of reaction. Similar, not exactly the same. Nitric acid, HNO3. Of course, that's a strong acid, so it's in solution. Now, what happens if you take a carbonate and combine it with an acid? If you take a carbonate and combine it with an acid, you're going to get a CO2 gas. That's one of the things you're always going to get. The other thing you're always going to get is water. So if you have carbonate and you add an acid to it, you're going to get water. So here's our carbonate, CO3, 2-. Let's see, the potassium ion is going to cancel out on both sides because you would have calcium nitrate over here, CaNO3. Those are in solution. They're going to cancel out. But what isn't going to cancel out here? Well, the H+. We've still got hydrogen ions. So there's our net ionic equation. Now let's check and see if it is balanced. It appears to me we need a 2 here. That'll make the charges balance to 0 on both sides, and it'll make the mass balance. So briefly describe a simple test. You can't just write flame test. That's not a simple test. Now you could put something like the gas You could probably do that. That's one test that we often do in lab. Or if you bubble this through lime water, it will turn the lime water cloudy. And so you could put something like this, turns lime water cloudy. Now the test we did in class, I think, was extinguishing this with a flame. Extinguishing a flame using this gas, using the CO2 gas. So there were the next problem, and we finished that part now. And that, remember, is worth 15 points.